we will make team databases that you'll both have access to, and then you'll still retain your individual private databases for little homework assignments here and there. Okay, so speaking of the databases, now that you have access to the database server, so homework 4 tells you how to connect and how to change your password and everything like that. So now that you have access, just remember that it's one server for everyone in the class, so treat it like it's fragile. It's fine. You can run queries as long as they take like a couple of seconds or something. But if you accidentally misform one of your queries and it ends up like joining every table with every table 100 times or something, kill your query before letting it finish, because that'll just eat up server resources. Yeah. How do you kill the query? There's instructions in homework 4 on how to find the ID of your process and how to terminate it. And don't write some script that goes and runs an insert a million times just to like make up a bunch of data. Keep your databases under 10 megabytes, for now at least. And that will be plenty for everything we need to do for now. Okay, and then finally, don't run queries during class. If you accidentally run something that chews up the server, like while I'm trying to do demos too, I'll run the process list command and I'll see who you are, and then might have to have words. Okay, any questions about that? All right, so remember to change your password first thing you do if you haven't already. Do that right after class.
So on the homework, on the last homework where we saw exact queries and get data, are you going to be checking for the exact way we pull up the data? Because there are multiple ways to get the same result, or it doesn't really matter as long as it runs returns.
So for your queries in homework 4, any query that returns the right result will be considered correct. Yep. You might lose points if your query is extremely weird or inefficient. But generally, there are a lot of ways to do things, and the SQL engine will turn most of those into an efficient query. Okay. So I want to recap a little example we did last week where we wanted to find all students younger than everyone in databases. And we were talking about the any and all functions. So we were talking about kind of nested queries, and we can use operators on those nested queries like in, not in, greater than any, less than any, things like that. So here is, let me fix these lights. Here's the query that we wrote for finding all students younger than everyone in databases. So let's look at the subpart, the subquery first. So all this stuff here is just finding the dates of birth for everyone in databases. Okay, and then we use that relation, and then we say, give me the name from students where that person's date of birth is greater than all of those dates of birth. And they're dates, so if we're talking about younger, then that means greater than all of the other dates, born after. Okay, and so that gives us novel. So I want to talk now about how these things work. So here's the query that we just ran, but I've kind of reformatted it, put some indentation in here, and split it up a little bit. So there's the inner part and the outer part. The reason I've formatted it like this is to make it look kind of like source code, like loops in a program. And that is because it is useful to think of these nested queries as nested for loops. Okay, so I have select something from students S, and then inside of that I have select something from students S2. So let's kind of look at this in terms of, I've now put the query so that the inner part is over on the right, the outer part is over on the left. So that inner part, select S2.dateOfBirth from whatever. I've left out the filter, but those, it returns a table or a list. So think of it in terms of programming terms. We have a list of dates of birth. And then I have, for all students, where that date of birth is greater than every date of birth in the other list. So I've highlighted in red here students S and students S2. Think of those as like for each loop range variables. So let's just kind of walk through this. So what this is going to do is S will be the first row in the left tuple, and S2 will be the first row in the right tuple. That's the first iteration. And then the inner loop moves forward 1. So S2 moves down. And then it's just comparing these dates of birth on every one. Okay, we've now reached the end of the right list. So S moves down 1, and we reset on the right list. So it's just a nested for loop. And that will move down, and so on. This is basically how we get comparing all these dates of birth to all these other dates of birth. Think of it like a nested loop. Okay, so if we translated that into some kind of Java-like or C#-like code, so for each student S, for each student S2 in some other collection. And then I have kind of the opposite condition. If S.dateOfBirth is less than or equal to S2.dateOfBirth, then we break. Otherwise, if we make it to the end of the loop, then we add that student to the returned result. And I put it as select, but it would be like, result.add, where result is some kind of array list or whatever. So I inverted the query because what we want to know is as soon as any one of those conditions, the opposite conditions, is false, then we know we can not add that student to the result. Okay? So this wouldn't be a break. This would be more like a return, or, I think I actually have a little error in the pseudo C# code here. But hopefully you get the point. It's a nested for loop, and you just apply some condition to figure out what to select. Okay? Any questions there? All right. So we talked about this exists operator, where it's a Boolean operator that applies to an entire multiset. So it returns true if the nested select is non-empty, and not exists returns true if the nested select is empty. Okay? So it doesn't matter what is in there. It's just asking, does anything exist or not? And this, since this operator usually works on a nested select like this, this follows the same pattern of we're going to have some outer loop and some inner loop. And the reason I'm talking about exists now is we finally are going to get to how do you do division in SQL. So find the students taking all classes. And I've got a much simpler version of these example tables just to make it smaller, simpler to look at. So the only student taking all classes here is Hermione. She's in 3500 and 3810, and then Harry is only in 3810. So if we did, in relational algebra, what we would do here is select out the proper columns from each of these relations, and then do the division where we want the divisor, basically, to be the list of all classes. Okay. So let me show you the query in SQL. It's going to look weird, and so I'm just showing it instead of trying to work it out from scratch. But we will go over why this is how you do it. So I have, it looks like a triple nested for loop, and I'm basically using where not exists on each of these conditions. So let me just run the query. Here it is. I had it already ready to go. And we get Hermione is the only one in all classes. Okay. Now let's work out why it works this way. So I have select s.name from students s. Okay, so that's one for each loop. Where not exists, select c.cid from courses c. So that's another for each loop. So I'm looping over students. For each student, looping over every course. For each course, looping over every enrolled record. And then finally, at the end, I do some matching. So where CID matches and where SID matches. Okay, so if we rewrite this in terms of loops, we have for each student S, for each course C, for each enrollment E. And those C, or S, C, and E variables, those are going to refer to one tuple from each of these relations at a time. Okay, so why does this implement division? Let's just kind of slowly step through what this would do. So the innermost select here. So I'm going to select a course ID if there is some record in the enrolled table where that student is enrolled in that course. Okay, so if there's some pair of SC, student course, that matches the enrollment records, any enrollment record, then I will select it. Okay? So if the student is enrolled in the course, then this will be non-empty, which means a non-empty set returned to this not exists. That will make that return false. A non-empty set using not exists on a non-empty set returns false, which means I will not select C. I will not select that course if the student is enrolled in it. Okay? So if for all pairs SC, if I have not selected any of those courses, then that means this middle select is going to be empty. And if that is empty, then this will return true. And thus, I would select that student's name. So basically what this is doing is, the innermost one is like, okay, for every pair of courses combined with this student, is the student enrolled in it? If yes, it'll select something. And then I have not exists to negate that. So if the student was not enrolled in a course, then it would be empty, and not exists would return true. And this middle one is basically saying, what are all the courses this student is not enrolled in? So if that middle one is empty, then the student is enrolled in every course. Question there? Yeah, so I'm using E, C, and S all inside of this innermost query, but they have been kind of declared in some sense before that because of the outermost queries. So yeah, you kind of want to read them from innermost, but you have to look at the entire query to see what's visible. So yes, the C here does refer to the range variable in the middle, and the S refers to the range variable in the left. Does that answer your question? Yeah.
So in
So inner query, yeah, inner queries can see the outer queries declarations. Outer queries can see inner queries declarations usually if they've been renamed or kind of exposed in some way. Back there.
So what exactly are you dividing here?
What am I dividing here? So this is like, so this is students divided by classes that they're enrolled in. This is like finding, take all student IDs and then divide them by a list of all course IDs. So for every pair of student to course ID, the only student IDs that will be selected out of it are the ones that match up with every course ID. Yep.
So basically, you have here, it only will work on the condition when we check for all courses.
Yeah, so this,
not 3 out of 4, not 2 out of 4.
yes, this is only dividing by all courses. So this is finding students enrolled in all courses. We'll see how to filter that down further in a second. So let's do the other case. Okay, so this was the true case where we have selected a student because that student is enrolled in every course. If the student is not enrolled in some course, then this innermost select will be empty for some pair of S and C, student and course. So if this is empty, then not exists will return true. And then we will select a CID. What we're basically selecting is the course that that student is not enrolled in. So if this middle select is non-empty, then the first select will be false, and we will thus not pick that student, meaning this student, that there is some course or multiple courses that this student is not enrolled in. Okay, this is all still very abstract. If we step through it with concrete tables here, and remember to think of them as loops, this will hopefully make more sense. Okay, so here are the 3 tables, and I've basically named them S, C, and E. Those are going to be the range variables that will loop through every row in each of their respective tables. So the loop is going to start out on the first row of every relation. So we'll get S is Hermione, C is 3500, E is the enrollment record for Hermione in 3500. And then this, all of this stuff here, this condition, basically what that is doing is making sure that this matches this and this matches this for the combination of rows that we are currently on stepping through this triple for loop. Okay, so I have highlighted here in red the tuples that the first iteration of all of these loops. Okay, they do match. 3500 matches from enrollment, matches the course, and SID matches the student's SID. So we will thus select the course saying, yes, Hermione is enrolled in this course. So the innermost select is non-empty, which means we will not select anything in the middle select because it's not exists. Okay? So moving on now, we can kind of just break out of the innermost loop because we've already found a true case. So we move on now to 3810 combined with 3500. So the SIDs match, but the CIDs do not. So we move on. And then we find one where all of them match. 3810 matches, student ID matches. So we select 3810, pass it up to the middle query. It negates it, returns false. Okay, now we're done with the loop. We can break again early because we've found one, and then this one's done. So we're basically done with the 2 innermost loops. And now we can say the middle select was empty, so the outer select says not exists, which results in true, so we select Hermione. Okay. Then we move on. This loop is going to move down to the next one, and all the other ones will reset. So we now have comparing Harry to 3,500 to Hermione's enrollment record for 3,500. No match. Move on. Harry compared to 3,500 compared to Hermione's record for 3,810. No match. Harry compared to software practice compared to his enrollment record for 3,810. So the IDs do match now, but the course IDs do not. So we've made it through everything, and we did not select anything in the innermost select. So that's empty, which means this not exists is going to be true. So we pick out c.cid, which comes from the C range variable. So we say, okay, 3,500 is selected in the innermost query. In English terms, what this means is Harry is not enrolled in 3,500. We're selecting the classes that the student is not enrolled in. So if that's not empty, we negate it again in the outermost query, which is going to give us false, which means we do not select Harry in the outermost query. And we're done. So this means whatever we have here in the selected list from the outermost query is the set of students taking all classes.
So if there was another course that Harry wasn't enrolled in, does that mean that the middle query would get like 3,500 comma the class?
Yep, if there was another course that Harry was not enrolled in, then before we were done with the middle query, then this would have like another entry in it. But it doesn't matter if there's any entry in it, then the not exists has a certain meaning.
In that step one with Harry, why are we selecting c.cid, like the 3,500 part?
This?
Yeah, if we don't do anything with it afterwards.
Yeah, so why are we selecting c.cid? We just have to select something that will make this non-empty. So we select the course ID, meaning that's one of the courses that Harry's not enrolled in.
You just put a constant in there, right? It's like one.
Yeah, you could like select true or something like that. Yep.
Does my HTML break out early and optimize?
Yeah, so this all looks very expensive. Triple nested for loop. It looks like an n-cubed algorithm. It will definitely stop early. It's not even a loop. It's going to do this with joins, which do, in some sense, boil down to loops. But think of it all in terms of tables and joins. It's going to filter down the tables to the minimum thing first, and then figure out the answer. It'll optimize all of this out. So yeah, you don't have to try to be efficient and do something like put a break statement in here to stop early or anything like that. The engine automatically does that. Okay, so let me go back to this is the query that we just worked through on the slides. It gives us Hermione. So let me show you the actual tables, though. They're a little bigger than the example in the slides. Let's do select star from students. Whoops. Select star from students. Okay, so we have some extra stuff in here that was not in the slide, and then I'll do select star from enrolled. Okay, so quite a few things here. Let me go back to the division query. So all students that are enrolled in every class. That's just Hermione, enrolled in all three of the classes. But what if we wanted to select all students enrolled in 3,000 level classes? Okay, so we have for every student, for every course, for every enrollment record. If we want to select just students enrolled in 3,000 level classes, then we don't loop through every course, we just loop through those courses. So we would come up to this part of our query, select CID from courses C. This is basically the middle loop. If I don't want to loop through every course, then I can just do from courses C where C.CID greater than or equal to 3,000 and C.CID less than 4,000. Add that to my filter. Now I have a shorter loop in the middle. Let's see, what did I do wrong? Yes, I do. Now I get Hermione and Ron. So let me go back to all of the enrollments. So students in all of the 3,000 level classes. There's Ron in addition to Hermione. Okay? So unfortunately, SQL doesn't just have built-in divide, but like with other things that it's missing, it's because you can make it up from other operations. Okay, so we're going to kind of just go through some more little SQL-isms that will be useful in coming homework and in the project. Just in general, there's lots of weird stuff in SQL that you could Google and figure out on your own, but I'll give you just kind of a primer of things that are possible. So strings have their own kind of special comparison operator called like. Basically, it's sort of a regular expression matcher. So it doesn't follow the normal regular expression syntax you're probably used to, but so instead of just saying where title equals or not equals or whatever, you can do like, and then so J means exactly a capital J. Underscore means any one character. Percent means any number of any character, including 0. So this full thing, J underscore percent M, means at least, so a J followed by at least one anything followed by an M. And the reason it's at least 1 is because the underscore means has to be 1, and then the percent means 0 or more. Okay. Yep.
This would only work if that was the entire string of that result, though. Like if you had, say, a sentence and you wanted to find this word in the sentence.
Yeah, so this only matches strings where the first character is J and the last character is M. If you wanted that somewhere in the middle of a sentence, then you would put percent on both sides of this whole thing. So let's just play around with that a little bit. I'm going to go to the chess database that you have access to for homework 4. So describe games. It has result, moves, game ID, black player, white player, and so on. Moves is just a giant string. It's basically a list of what moves were played in that game. So let me do select moves from games. I'm not going to select all of them. I'm going to do limit 2, because selecting all of them would just be a huge dump of text. So here's, the formatting's kind of bad on this projector, but here's the first game, list of moves. Here's the second game. So they follow a certain format. This is PGN format, where it's always move number followed by the move itself. So 1 dot and then a move, 2 dot and then a move. So if I wanted all games where the opening move was e4. So that's, if you know anything about chess, that's kind of a very common standard opening where you move your king pawn forward. I would do select moves from games where moves like (1.e4) followed by anything, and then I'm still going to limit it. Okay, so now it gave me, there's some game with e4, there's some game with e4. So selecting, if I took off this limit 2, wouldn't be that useful. But I can do, say I just want to know like how many. I can select count. So this gives me how many games were played with that opening move. So we saw limit, or question first.
Is limit just random? It doesn't select the top 2 or the bottom.
So is limit random? It's not random in the sense that it's not going to like explicitly shuffle the output, but if you don't specify what the order means, then it's basically like whatever order they were in from the original select. And then if you do limit 5, it'll just give you then the first 5 that were in that same order. So sometimes it's like the order they were inserted. Sometimes they are ordered by one of the keys in the table. Yeah.
How does that differ from, say, you want to select top 5? Is limit required to be placed at the end where top is at the beginning?
How does this differ from select top? Yeah, this is kind of just like a different syntax. Yeah. Top, though, is combined with an ordering, with a sort. So limit 5 just says whatever the order is in, just cut it off after 5. Yeah, so count star. We'll get to count in a second. Okay, so limit is also useful when combined with order by. So if I want to find the smallest thing or the smallest 5 things, so this is kind of like top, but I can do, limit however many and then order by whatever field, so it'll sort it, and then cut off the top 5. And then if you want to sort descending, you just do order by whatever DESC. So both of these are kind of a shortcut for max and min, which SQL also supports, but it is different syntax and has different subtle requirements. So this order by, does this only work with ints? No, SQL can actually compare strings. It can compare dates, floats. It can compare almost all of its built-in types in the way that you would think and hope makes sense. Okay, so this count that I showed, this is called an aggregate function, and there are a bunch of these. Basically, what they do is they take a whole bunch of tuples and they compute some kind of aggregation out of them. So count, we saw exactly what that does. It takes an entire relation of tuples and distills it down to one number. Same thing for max, min, sum, average. All of these take a whole bunch of things and basically filter them down to just one number with some kind of computation involved. So you can sum everything from a column, you can average everything from a column, and just because of the syntax, they kind of take something in parentheses. So it makes sense for max, min, sum, like max of what column, min of what column. For count, as you saw, I just used count star. It doesn't really matter what I pick here because tables are square, right? I could pick any column and it would have the same count. So usually the syntax you'll see is just select count star because putting in any particular column in there just kind of just confuses what you're asking for. Yep.
So for like a max and min, can you specify columns?
Yeah, so for max and min, I'll just do a little example. So select max PID from players. And PIDs are just IDs, so the max one doesn't really have any meaning, but just as an example, that's how it works. Okay, so we saw count. Useful when you don't want the information itself, you want to know how many things there are. And this can be used when your relation has lots of duplicates in it, where maybe you do want to know how many, so you would select something that has a bunch of duplicates in it and then go like manually count them to see how many there are. It's obviously better to just have the engine count them for you. So if I wanted to know like how many copies of Harry Potter does the entire library have, something like this. So just do the natural join, giving all copies of them, and then just count them. So we kind of saw a bit of a demo, but let me take this a little further. So select count star moves from games where moves starts with 1 E4. Okay. I could also do where moves like that and result equals white. Okay, so that gives me, when white played that move as the opening move, how many times did white win? So this would kind of indicate that maybe that's not the best opening move, but this is not really a complete chess database. Some of this stuff is very hand-picked, so it doesn't mean much. But this is kind of showing SQL can do a lot of things for you. You can now take this number divided by that number and give you the win rate for that opening move. This is specifying white 1, yeah. This is a different syntax from the syntax you've seen where it would be 1-0. The actual chess database on the server just translates that into either W, B, or D, for white, black, or draw.
So is it picking from every game? Or?
So this is picking from only the games where the moves starts with that.
So it could be white or black first.
White always moves first in chess.
Oh.
So that's just kind of, you just have to know that. Okay, this is a good point for a break. So let's take a 5-minute break now and then move on. Let me see if I can scroll up. Yeah, so I said you could, if you wanted to find the win rate for that opening, you could take this number divided by this number. Or you can have SQL do that. So here is, let's go back to select the number of moves where the opening was E4 and white won. Okay, I'm going to put that into a nested select. So that gives us one of those numbers. And then we have to name it as wins. Okay. And I'm going to name the count. Select count as C. Because if we want to be able to use that later, I would have to either retype count or just give it a name. Okay, and then I'm going to do join. Let me just basically copy that, except I will remove the part where white wins. So this is number of wins for E4 opening divided by total number of E4 openings. I'll just call that total. Do we want to rename the second count? Yes. So that'll be wins.c and total.c. Yeah. And let me just select star from that. Let's see. What did I do wrong? Comma. Oh no, I want where. So I count star as C where. No, you're right. I just want to take out the moves. So I count star as C from games where moves like that. So I count star as C from games where moves like that. Okay, so that gives me a table with, I could have named C better, like C wins and versus C total. And then instead of select star, I can do select wins.c divided by total.c. So you can just do math in SQL and kind of treat it like a little calculator. Okay, so that gives me the win rate for white for that opening move. Yep.
I'm curious, what's the loss rate?
What's the loss rate?
We just change it to.
So we would do and result equals black. So the loss rate is lower, and there are a lot of draws in here, which is why those don't add up to 1. And again, don't treat this as an accurate chess database. There are very specifically picked games in here that might totally skew these numbers. Okay, so we're talking about these kind of aggregation functions, and there's something that usually goes along with these in a useful way. So we can ask SQL for certain groups. So like, there's tons of data, tons of rows, columns. It's often useful to group them by some criteria. So let's say I selected the major from every single student. So if students had a major column in it, and that was the entire thing, then if I group them by major, basically it picks one representative row from every group that I've grouped by. So now I get only one copy of CS, even though there were actually 2 of them. And this looks a little weird when you select other things. So I'm selecting just major. What if I select star here? It will give you something. So group by gives you one representative row from every group. I'm grouping by major, so there will only be one copy of each major for all of these rows. But since I'm selecting star, it gives me something else from every one of those groups. So even though there are 2 CS students, it's just given me one of them, the one named Jim. So this is usually not that useful. You usually don't select star here. You usually select just the thing that you're grouping by plus maybe something else. And so let's think about this for a second, though. Plus maybe something else. I said you usually select something else. So how is group by useful? So isn't it kind of the same thing as just select distinct major, right? And we saw that if I'm trying to select other things from the group, if I just select everything, then it doesn't really give me anything useful. It gives me one representative from every group. So yes, these 2 queries are the same if that's exactly what we're selecting. If we're just selecting the thing that we're grouping by, it's identical to select distinct. But what we usually do is combine group with some aggregation function. And that way the aggregation function only runs on the items within each group. So by this we can do give me the average GPA for all students in the CS group, or the average GPA for all students in the physics group, or the count. So count is an aggregation function. This gives me how many art students are there, CS, physics, for every single major. Okay. So there's that other example. Give me the GPA, average GPA for each of the groups. And the CS students have the lowest GPA because CS is the hardest. Yep.
What does the schema look like for when you do the count?
What does the schema look like the output here?
Like if you wanted the max of that column, the second column.
Okay, so if you wanted the max of the second column, you would take this, say the bottom query here. You would take that, put it inside a nested select, rename the count so that you know what its name is, so you can refer to it, and then do another select max of that renamed thing. I'll actually show that a little later. Yep.
You said that group by one distinct representation from how is it that count is getting all of the different
So group. So if I just do select something grouped by, or select star grouped by, it's going to give me one representative row. If I combine that with an aggregate function, the aggregate function will work on the whole group and distill that thing down into one number for the group. So if I did select star comma count, it would give me everything from the one representative that it picked, plus it would give me the aggregate count from the entire group. So this might become more clear in a second. We'll kind of go through how the difference between groups and representatives from groups.
Don't you have to specify all the select attributes in the group by unless this is an aggregate function? Otherwise, it's going to throw an error. For example, if you have to select star and then group by, and you just, for example, group by one certain column, and then you don't specify that, whatever you have to select in group by.
So if I like star from something grouped by major,
right.
It gives me something like
Without
this.
being able to aggregate it.
If I combine this with an aggregate?
Without aggregate. If you select, let's
Yep.
say, student ID and course ID, and then you group by course ID.
Yep.
Will that allow you to do that?
Yes. Here's an example. So I'm selecting star instead of student ID and course ID. But you could easily just select fewer things. What this is doing, so this is grouping by major, so that you're guaranteed that the major column here is going to be unique. And what is the rest of this stuff? It's just one representative from each of those groups. So if I go back, there are 2 CS majors in the entire school. If I group by major, it distills it down to one representative from each. And if I select other columns from it, the fact that I got Jim as the CS major is just that's the representative that it picked. There are other CS students, and we don't know their names. So group by is usually not used when selecting everything like this. It's usually used in conjunction with an aggregate, like this. Okay. So let's use group by a little bit to figure out. So as an example, figure out the number of students in each class versus the number of classes each student is enrolled in. Okay, so we have 3 tables here. Some of them may not even be involved in this. Basically, the table we're interested in here is enrolled. So this is showing me all of the students in every class, and also kind of in another way showing me all of the classes every student is enrolled in. That's what that table gives us. So if I wanted the number of students in each class, what would I group by on the enrolled table? Group by CID, and then I can aggregate using count for each one of those groups. So if I select count, comma, CID, 3 students in 3500, 3 students in 3810, 2 in 5530. And the other question was, give me the number of classes each student is enrolled in. So the group now, we want SID, we want to know for every student, what is sum count? And we want to group by SID instead of by CID. So Hermione is in 3 classes. Whoever 2 is enrolled in 2 classes. If we wanted to get their name, we could just do another join, treat this as a nested query. Yep.
I'm just a little bit confused about the count. It seems like it's counting all the courses or all of the IDs, but how does it know to count like everything else?
So how does it know to only count by group instead of everything? It's just the SQL interpreter knows that when you see an aggregate function combined with group by, it applies the aggregate function to each group instead of to the entire thing. Yeah, you don't specify that in the query, it just implies that.
So if you left out the group by, it's going to give you a total number of courses.
Yep, if we left out group by, that just gives me how many SIDs are there in the, or how many rows are there in the enrolled table.
So why did it give SID 1? Because that's the first one.
Yes, excellent question. So I'm selecting, let me just select count. Okay, that makes sense. If I select count and SID, why does it give me 1? So remember, count is an aggregate function. It's going to take everything, every single row, and distill it down to 1 number. Then I'm also selecting SID, so it has to select some representative from the group. I'm not using group by, but it's implied that the entire thing now is the group. So it's just picking the top one. Okay, so these aggregate functions, say we wanted to filter based on the result of an aggregate function, like find all classes with more than 2 students in them. There's a little annoying in SQL, but there's this, you have to use having instead of where. So having applies to the result of an aggregate function. Where applies to any other condition we might want to use. So it's just a little annoying. You have to just get used to it. That's just how it is. So select something from some aggregate function, so count, and then I can say having count equals 2. This is kind of bad form because I'm basically retyping my aggregate function. So what you would usually want to do is give the aggregate function a name, and then you can use that name in your having clause. Okay, so having versus where. Having always shows up before group by. Where shows up before group by. Having shows up after group by. So having filters rows, group by filters by groups, or filters by aggregate functions. So as an example, let's say I want to find all the students who have earned only A's and are in at least 2 classes. Okay, so first we filter using where. We filter out the students that have earned A's. And then we take that subquery and group it by student ID, and then take the count. So which students are there where they have 2 or more A's in their classes?
So this slide doesn't really do this, but in the last slide you had where C equals 2. The implied in the query would be that you know that C is going to be 2, so what if you just wanted to select the major? Just spit out the major name instead of the major name.
So if you just wanted to select major, that would be kind of trickier. You'd have to contort your query a little more to filter that out, but you could basically put this into a subquery and then just select out the one thing from that.
So I guess my question was like, so you have to count star as C. Did you say having count star equals 2 without specifying it first?
Yes. Yep. Okay, so, okay, one more question, yeah.
Sorry, so from the SQL I learned, the group by and the having comes first before the selection is done. So how can
So you've learned that group by and having comes first.
yeah.
There are different, yep, there are different engines treat SQL differently.
Okay.
Yep.
And so the having can be what the selection.
MySQL may support that syntax as well. Actually, I've never tried it, but yeah, you'll see a lot of different forms of these queries, for like one for Postgres, one for MySQL, one for Oracle, one for Microsoft, whatever. Okay, so to kind of try to clarify this a little more, the aggregate functions versus rows. It gets a little confusing because group by returns one representative from the group, and aggregate returns one number, which is a distillation of all of the rows. So if we're trying to do some combination of both, like give me the name of the cheapest product from every department in a grocery store. So here's a little table. I have produce in a bakery, carrots, peaches, cake, bread. So let's forget about the name part. Let's say I wanted to find just the price of the cheapest item from each department. I could group by department and then do like min price from those aggregates. But if we do want the name, let's say this is my attempt for that query. So I select department, minimum price, and name from items. So this table is called items. And then I group by department. Okay, so department and name will be some representative of every group, and min price will be the aggregate of each group, the minimum aggregate of every price. So what that would give me is this table. So for produce, the minimum is 70 cents and the name is carrots. For bakery, the minimum is $2 and the name is cake, which is wrong. So cake, the name cake does not match up with the price $2 because the name cake just came from whatever representative the group by picked for that group, but the 2 came from the aggregate of the entire group. It doesn't automatically like match them up like you might think. Why does it not do this? Well, as another example, let's use a different aggregate function. Let's use average. So if I wanted to find the average price from each department, what would it even mean to try to pick a product name for average? Right? Like there is no product associated with the average of 0.925 cents. So what it does is it just picks the representative from the group, and that's the name that it gives you in the select. So it doesn't make sense to even try to do this with average, but it does make sense to try to do this with min or max. Like you do want to know, there might be a name associated with the min or the max. So you want to know like bread is the cheapest from the bakery and carrots are the cheapest from produce. So let me just kind of clarify what's going on here again. So group by, if you just select everything out of a group by, so select star from items, group by department. What it's going to give you down at the bottom are the rows that are not grayed out. That information is still there. So the SQL engine still has the entire group. It's just going to give you one representative. The rest of the information is there, and you can use it in aggregate functions. So if I do this broken query that we had, select department and min and name, Okay, so it's going to give me department and name from some representative. It still has the entire group, and it's going to use that to compute the min, and then give me that in the answer. This is why they don't match up. The results of an aggregate function do not match any particular row from the group. Okay. Any questions there? So then you might be thinking the next step, well, what if we do want to match up the min with a name? Well, we can just do another join. We can do a join. We can take this table on the right, join that with the original table. So it's kind of like a self-join. And then we just find the ones where the price and department match up. So find the one where there's some product from produce that has a cost of 70 cents. Get that product's name.
Could you also do that with having? Or no? Like having price equals in price or something?
Could you do that with a having? No. So it's still not going to, the having filters based on whatever the aggregate is that your condition has in the having. It still only has some representative from the group. Okay. So if we wanted to get the name of the cheapest item from each department. So we have that thing in the middle there. Select department and minimum price. And I've renamed it as P from items grouped by department. Okay, that's going to give me some temporary table that has department combined with minimum price from that department. And then I join that with the original table. And then I just do a filter where department matches and price matches from those two tables. Okay. So another example. So let's say I want to find the name of the oldest student in each class. You would have to do some kind of join just to get dates of birth matched up with the enrollment table. You can do that. You can join those together. Then you can do a group by, but it's still not going to give you the right representative name from that group because you'd be grouping by CID. And then you would join that with the students table again. So I'm kind of just talking through it. I was going to show the demo, but in the interest of time, I'll leave this as like a future question. Basically, the summary is for these aggregate functions and group by, they do not automatically match up some row from the result of the aggregate function. And as an example, average, there is no row associated with the average. All of the aggregate functions work that way. There is no row associated with it, even if there could be. So if you want it, you have to do another join and then just pick out the right items from the original table. Okay, so there was a question, what if we wanted like the major with the most students in it? So something like select max of count. That doesn't really work. You can't use an aggregate function on the result of an aggregate function unless you first put that first aggregate function into a nested select. So this inner select here, select count star as C, and it's important to name it, from students grouped by major, and then I can select the average of that column from the nested select. Yep.
How does it know? Does it just know to automatically compare the numbers as opposed to the names? Oh,
Okay. Okay. So I want to move on. In the interest of homework 4, you're dealing with dates in the chess database. So a date, the built-in date type is kind of like a compound type that has a year, a month, and a day. Some versions of it also have hours, minutes, seconds. We'll think of it just in a basic way as just having year, month, and day. So it's a compound type, but SQL lets us use the Boolean comparison operators on it. So I can do something like, is this date greater than that date? And it'll basically say, is the date later than the other date? You can do less than, equal to, not equal to, all of that. And notice that I'm comparing here. So date of birth, that's a date, and it's from, say, the students table. I'm comparing it to what looks like a string. And that is a string in SQL, but there's an automatic implied conversion because it knows I'm comparing to a date. But it is always better to be explicit, and you can sort of use this date constructor. It's not really a constructor. Think of it like that, though. You put the string inside, and then this is explicitly comparing a date to a date. Okay? So if we want to get just the year out of a date or just the month or day, there are these year, month, day operators that take in a date, and then they will just return a number, like an int. So it'll be like 1999 or 2 for February. And so dates in SQL are kind of weird in that you can do arithmetic on them. So today, 2019, February 11th, minus a date of birth. So that would, in theory, give us a student's age. Let me just kind of play around. I'm going to use LMS2 is my scratch copy of an actual LMS from the final project. Let me just do select star from students. So I have a lot of students in here with sort of realistic dates of birth and majors and everything like that. So if I do select date, and I want today, so 2019, February 11th, minus date of birth from students. Let's see. Oh, yes. I need to close that there. Okay. It gives me, it might as well be null. I mean, like this is just as useful. It gives me some weird number. It's basically like it's converting both of the dates into an integer and then doing a subtract. The format of that integer, don't really worry about it because this is not how you would normally do this. Now, another thing you might try, so let's say I just want to know, like, in terms of the number of years, how old are they? So I could just do select 2019 minus year, date of birth. Okay, that's looking more reasonable. There's some really old students in here. But let's go back up and look at their actual dates of birth. Yeah, so, you know, there's some people born in like 1981. So this seems to be kind of working. Let's look at this person right here, though. So their date of birth was in 2000, February 15th. February 15th is a few days from now. And let's see how old it thinks that person is. From students where F name equals Jane. That's that person. So it thinks they're 19 years old, even though their birthday is in 4 days. They're technically only 18 right now. So if we really wanted to do this, we would have to do something like, and we would have to compare the month and the day one at a time. And you know, you could do it and it would work, but there's a better way to do it. So plain old data arithmetic like this doesn't work. You could try to do this. Select 2019 minus their year, select February minus their month, and whatever. Lots of problems with this. First of all, that starts to get complicated if you have to include year, month, and day in your comparison. Second of all, you'd have to rewrite that query every day to figure out how old people are. So there's this built-in timestamp diff function. Instead of using subtract to compare dates, use this to compare the difference between dates. And it counts for leap years. So let's rewrite this. I'm going to select timestamp diff. I want the difference in years from date of birth to today. And I'll make that specifically a date. Now, it correctly tells me that she's only 18 years old. Yes. So yes, the other question is, I'd have to rewrite this query every day. So instead of this, I can use current date. Now that query works every day, no matter what, and it gives me the correct number. Okay, one more thing before we wrap up. What if I select days? Oh, it's just day. So 6936. Okay. Let me actually change that to exactly the date when that person would turn 19 years old. So 2019 02 15 gives me 6940 days. And if I select 19 times 365, gives me a different number because this result is accounting for leap years. So always use timestamp diff when dealing with dates and subtractive comparisons on dates. Okay, we'll see you next time.